Hello, in this video we're going to find a limit and we're going to do it using infinite series. Let's go ahead and get right to it. Solution. So this is the limit as x approaches 0. We're going to start by replacing e to the x with an infinite series, which is 1 plus x squared over 2 factorial plus then minus, and then 1 plus x. Let's distribute the minus 1. So minus 1 minus x all over x squared. Oh, and look at this. Some stuff cancels. We lose the 1's. We lose the x's. So this is equal to the limit as x approaches 0. So here we have x squared over 2 factorial. The next one is x cubed over 3 factorial, etc. That's in the numerator. And the denominator, we have x squared. So now what we can do is we can factor out an x squared from the numerator. So this is equal to the limit as x approaches 0. So pulling out an x squared from the numerator, we have parentheses 1 over 2 factorial plus x over 3 factorial plus x squared over 4 factorial, normally that's x to the 4th, plus, like that, over x squared. These go away. So this is going to be equal to the limit as x approaches 0 of 1 over 2 factorial plus x over 3 factorial plus x squared over 4 factorial plus ... And then you can plug in 0, so you just get 1 over 2 factorial, which is 1 over 2. And so there is your answer of 1 over 2. Let's go back to the original problem just to reflect on the actual question. So we have the limit as x approaches 0. It's easy to get hung up on all the series stuff. So let's look at what we were looking at. And then here we have x squared. So basically we have our function in series form, and we're just subtracting away the first two terms. And then we're taking the limit. So we're eliminating the linear term and the constant term. If you plug in 0, you get e to the 0 minus 1 plus 0 over 0 squared. So you would get 1 minus 1. E to the 0 is 1, so you just get 0 over 0. So you can use L'Hopital's here. Let's do that. Let's use L'Hopital's rule. L'Hopital's rule says that whenever you have this happen in a limit, whenever you have this type of, it's called an indeterminate form. That's what this is. Whenever you have one like this, 0 over 0, you can use L'Hopital's rule, which says you can just take the numerator of the numerator. Derivative of e to the x is e to the x. Here, this is going to be 0. And then the derivative of x is 1. You're just going to get a minus 1 here. Then here the derivative is 2x. And what happens when you plug in 0 now? Well, you get e to the 0. So you get 1. So you get 1 minus 1 over 0. 2 times 0 is 0. So you get 0 over 0 again. So you use L'Hopital's again. Use L'Hopital's twice, right? Derivative here this time is going to be e to the x. Derivative of negative 1 is 0. And the derivative of x as 1, you're just going to get 2. Now you plug in 0, you get e to the 0 over 2, so you get 1 over 2. So you get, you can get the same answer using L'Hopital's rule 2 times apparently, as we did with series. So that, I just did that to check my answer because I haven't done this problem. So we got the same answer both times. So it's probably good. Hopefully you've learned some mathematics. Take care.